Hi, it's Marcus Donnelly here again. In the more than 3 years since I made the first video, the Bokeh Visualization library has moved on quite a bit, new features and performance improvements, and I've made some changes to my app. So very grateful to the more than 1,000 people who viewed the first video, but here's a quick update showing some new features and looking at another ocean model dataset. So I'm running the app as before, just using the Bokeh server, and here it is. I haven't done anything with it yet. We're going to be looking at data from the HYCOM ocean model. You can get data from their website here. If you follow some of the data access links, you end up with this OPenDAP server page here, which is their hindcast data from all the way from 2000, the year 2000 onwards. So as per the first video, we just grab the OPenDAP URL, pop it into the app and open it, and then we'll get the dataset descriptor structure there, which has all the information. So I was going to look at data around about, their model data around about the start of October 2019. Their time base starts at the start of the year 2000, so if you work it out, it's about 173,100 hours. So if we look at the time dimension variable, we'll just plot that so we can find the right index for that value. So look at the plot options, it's just a line plot. So we'll get the data and plot it. That should be fairly quick. So use the Bokeh wheel zoom, and 173,100 is about about 6,100. The index about 6,100. That's close enough. Okay, so we'll now go to water temperature, which is what we're interested in, and change that to 6,100. So we're just getting a single time value here, and we'll get all of the data as a function of depth, latitude and longitude at that time. So if we look at the plot options, we'll plot it against long and lat with depth at the variable. So now we'll get the data. It'll take a short time for the data to come through. And it should display it just now. So there we go. So there's the Gulf of Mexico, a very interesting area oceanographically. You've got the warm water coming here between Cuba and northeast Mexico, the Yucatan Peninsula, and this is the Gulf of Mexico loop current, which curves around to the east here and exits through the Florida Straits. And while it does that, it spins off warm core eddies, which travel north and west towards the south coast of the United States. So a very interesting area, and I've got here a Bokeh color map. This is actually a bespoke class I wrote, which is a color map with some other things attached, like a depth slider. So we're looking at the surface here, but if I move the slider, you can see how things change with depth. Notice the color bar at the bottom is updating automatically. This is more or less what I had before in the first video, but you can see how much more responsive it is now. And this is due to a couple of things. Bokeh has a faster binary transport way of getting data from the server to the client, but I've also used a bit of JavaScript instead of server to update the depth slice. And so there's a couple of reasons. It has a scanner as before, so you can look at the depth profile. You can see how the temperature decreases with depth. Another new thing in the app is this white dashed line here is a slice across this section, which shows you how things vary with depth along that track in the right hand plot, which is here. The white bits are where you've hit the ocean floors, there's no data. So if I change that slice, say I want to look across this short section here, just where the warm water's traveling northwest, it takes a moment to interpolate the data and send it back through to the client, but you should see this update in a minute. So there we go. And I'll just use the box zoom so you can zoom in and you can sort of look at the details of the variation through there with another scanning cursor there as well. So that's quite useful to be able to do that. So we can look at variation with lat long and depth here in a fairly sort of intuitive way, hopefully, but we might want to look at the data in other ways, for example, do a time evolution. So if we go back here, We'll now set the depth selection to just the first depth, in other words, a sea surface. Let's set the last time index to 6,200 hourly data. So this is 100 hours, in other words, just over 4 days. Look at the new plot options, and we've got, yeah, against long lat with time as variable. So let's do that. It might take a short time, more than before, because it's got a bit more data to download. As I was saying in the first video, you can, any variable that the server will give you can be viewed in any number of the available dimensions by just using these selections, which I hope is quite a helpful, intuitive way to be able to examine data. So in a moment it should visualize, and we can look at how things vary with time at the sea surface. So there we are. Similar looking plot to before, but now when we change a slider, we're changing time. So as an hourly basis, if I move it, you can see the daily variations basically. You can see temperature changing throughout the day, as you'd expect. We've got about 4 days worth of data here. It actually helps to make the temperature axis constant. So if I say change that to say 26 to 32, update the display, then you can, it's a bit more of a sensible comparison between times, because you're keeping the same color bar range, so you can see it a bit more effectively now. And so that's quite nice to look at that time evolution. You can clearly see the loop current moving sort of eastwards, north and eastwards. So interesting to be able to look at the ocean circulation that way. Well, that's about it for this video, and just thanks again to the Bokeh team for producing some terrific software. The app I've written, I've put the links to the software, the GitHub repo, and also you can get it from pip, and that's all in the video description. Thanks to HYCOM as well for making their great ocean modeling data available, and I hope that's been interesting. Many thanks for watching.